Let's start by briefly introducing yourselves and summarizing your industry education and professional background.
My name is Michael Marshall. I have a bachelor's degree in civil engineering, and I've been working in the bridge inspection industry for about 11 to 12 years now, mostly with Stantec. And so we work with bridge inspection, asset management, anything post-production with bridges. And my official title is bridge inspection engineer and UAS bridge lead for Stantec.
And my name is Alicia Llorens. I've been working for the last 11 years supporting professionals across different industries to successfully integrate drone photogrammetry and mapping data into their workflows. I started my career in one of the first drone manufacturer providers, drone manufacturers in Europe, Gatewin, who then was acquired by Trimble. I started my career as a customer support engineer and then progressed into product engineering, business development, and finally technical sales or solutions engineering. My background is in surveying engineering, and I have an executive MBA as well. At Skydio, I work as a solutions engineer. I help our enterprise customers, such as Stantec, to capture and consume 2D and 3D data in a smarter, safer, and less costly way.
Michael, a good question I've got is, how does one become a rope access bridge engineer? And I'm sure that that's different than just a bridge engineer, because I know that they all have some levels of difficulty. But you know, I saw the video of the O'Callahan Bridge in by the Hoover Dam, and that seems kind of special. That seems more like really technical rock climbing. So how does one get involved in that? I'm wondering, is it like, are you an engineer and then you kind of get tilted that way because it works out, or were people rock climbers and then decide, hey, I can get into engineering and do this? Or how does it often work?
I think it's a mixture of both, really. In our group, specifically, a good number of us, over half of us are rock climbers recreationally while we're maybe in school to become engineers, and end up becoming rope access technicians as a result. Some of us, like myself, I was not a recreational rock climber before I became a Sprat technician. It was just something that was really interesting to me, and you especially went to the coursework. So we're all underneath an umbrella of SPRAT, which is the Society of Professional Rope Access Technicians. So we're referred to as rope technicians, essentially. And each of our bridge engineers who is on rope follows those guidelines and takes those coursework. And usually it's about a 1-week course with a rigorous test at the end of the week to be a part of the rope to start off with level 1 rope access technician. And then after 500 hours of operating under rope and another week-long course and rigorous test, you move up to what's called a SPRAT level 2, and so on and so forth. The highest is level 3. And I would say most of our group are rock climbers or do something recreationally that's similar, but in the end, we all come underneath the same umbrella of SPRAT. Okay,
so a typical bridge engineer who's got to go look at maybe a 1-2 story bridge, and there's some difficulty there. You've got to, but it's like getting on my roof as opposed to doing serious rock climbing. Do they have to have any kind of certification, or is that just part of being a bridge engineer?
Yeah. I always tell prospective students that want to become bridge engineers that your testing and your studies never end, ever. So there's a lot of different certifications. There's a coursework, even after my bachelor's degree, there's a coursework for becoming a bridge inspection team lead. There's coursework for becoming a SPRAT team, rope access technician. There's coursework for even looking at what we call fracture critical or they've changed the name. It's a non-structural NSTM, non-redundant steel member and tension members. But essentially you need different coursework and different tests to be in certifications for each one of these types of bridges. And I would say it depends on the bridge and as to which one of your certifications better applies and which ones you need. SPRAT is not for every bridge, just like fracture critical or something else is not meant for every bridge.
Is the one at the Hoover Dam, the one that was on the video, is that require like the highest certification? Is that a level 3 kind of job?
Yeah, exactly. So with SPRAT, level 3 being the highest, we have to have at least a level 3 on site at all times and ready to go. That means that level 3 is not on rope. They are up on the deck and they're coordinating and ensuring the safety of everyone else. And then there's everything from levels 3s down 2s and 1s all on that job on rope at once. But the rule is to have a level 3 at least there for just about anything that could happen.
Okay, so not everyone needs to be at the highest level. There just has to be some kind of high level supervision.
That's correct. Yep.
Okay, as far as costing, I'm guessing this is true, but are the different levels of rope engineers more costly by the man hour as opposed to regular bridge engineers?
Not necessarily, no. I mean, yeah, question. On an average, I would say no. But usually when you, like, for example, when you go from level 1 to level 2, it's 500 hours plus a rigorous course week, right? So by that, you're improving yourself as a bridge inspector and furthering yourself in your industry. So the expense is higher, right, for somebody who's a level 3 versus level 1 in some cases. But in terms of comparing a rope access technician inspector to a regular inspector, there's not a big jump there.
So I want this article to be a bit about, bridge inspection in general, but also obviously a little bit about this bridge in particular. I think is going to be a focus, certainly graphically. What can you tell me about this iconic bridge that you were working on, either one of you? Things that personal experiences, what you found special about it, things that maybe I couldn't find on an internet search.
I can start with the overview at least. So before we got to and from Nevada and Arizona over there, historically using the Hoover Dam. And to move people essentially away from the dam and put more of traffic towards a bridge, for example, than putting it on a historical monument. And in turn, it became a very historical bridge itself. So I would say it's a different beast in its own regard. It's not just high up there, but it's a different type of construction that we're not used to seeing. It's just monumental in terms of what you're seeing with the Hoover Dam in the background and then the Colorado River on the other side. It's something that you don't get to see every day as a bridge inspector.
Yeah, it was probably one of the largest infrastructure project that I've done yet with Skydio, or actually in my professional career. It was extremely it was incredible to have the opportunity to be side by side working with the Stantec team. The level of stress and different environmental factors that they need to deal with throughout that inspection process is just incredible, the work they do. So yeah, it was really interesting to be part of that. And our kind of like collective goal was to assess or evaluate the value of utilizing Skydio and autonomous drones for bridge inspection workflows. But we had like the entire team, on ropes, hanging down the Callahan-Tillman Bridge. It was just really interesting projects. And again, I can't say how much it was appreciated the opportunity to be there with the Stantec team.
That's great. I've been on the dam several times. So I've been up close to the bridge and never once thought about trying to climb it up or down. So good for you guys. So I want to know a little bit about why Stantec is adopting drone use in its practice overall, particularly for bridges and projects like this. But I'm sure that there are other uses. Are the primary drivers safety and cost, or are there some other areas that maybe aren't quite so obvious?
I think it's across the board. I mean, the obvious ones definitely are safety and costs. We're putting we're on the road less, we're using less time out there. That's a cost and safety thing, one and together. But one thing that is happening, when you think about a bridge inspection report, a report that comes from me to essentially the bridge owner or the client, the DOT, or whoever that might be, is typically a black and white text with some photos associated with it. We're trying to tell our story in a black and white and essentially a 2D picture. And as all of our politicians are saying, our infrastructure is very critical nowadays, and it's very important to us to maintain everyday life here in the United States. So, to put our bridge owner there in the scene in a 3D world and put them in that environment, show them what's going on, not just with the bridge, but what's happening around the bridge, what might be causing certain highlight areas. It's to immerse them in there so we can make better decisions with our funds. And keep those infrastructure, the bridges, the tunnels, anything we're talking about, upkeeping them to the highest regard with that 3D model.
I think if I can add, if I can piggyback on what Michael, what you said, for me, one of the key takeaways of that project was that, drones and drone data are yet another tool in the inspector's toolbox. And it provides that better information and better views in matter of minutes, hours, without kind of like the complexity and risk of traditional methodologies, if I can say it that way.
So talking about those reports a little bit, do the drones make it easier to take many more photos involved? Is it recording video as well, and any other type of sensors?
I mean, yeah, we're taking video photos, the 3D model. I mean, I always say a picture's worth 1,000 words. I always like to see as many pictures come back from the field as possible, but to then take it to the next level and piece them together in terms of either a video or a 3D model, that picture is now worth, you know, exponentially more to the view of just seeing what you're looking at on site. Because many times our bridges are not in environments, especially in this case, I can't necessarily put everyone on a rope and show you exactly what I'm looking at while I'm on the bridge. But if I can spin you around and take you safely from your office into that world and show you exactly what I'm seeing without any text, without pictures, like immerse you into it, it really puts the understanding throughout. We can explain ourselves a lot better.
Are there any other sensors being hooked up to go along with the drones, like you know, something on the ground, or is the drone pretty much acting as the universal sensor recorder with maybe a few photos by the people?
You talk about LiDAR or thermography or something else. I mean, thermal is really beneficial when you talk about bridges. We're looking at specific things like delaminations in bridges. That's helpful to put on drones. So the drone essentially houses a lot of the different tools that we could use in a man or a conventional inspection right there compacted into one unit and get it up close to the bridge, if that helps.
Sure. And Alicia, can you maybe just kind of, while we're talking about this, kind of fill me in on the tools that are inside the drone was used on this bridge and similar projects?
What makes Skydio unique is, you know, everything we do. We have Skydio autonomy at the core of, you know, all Skydio applications and platforms. So basically, the drones are equipped with 6 4K navigation cameras, 3 on the top and 3 on the bottom, and a high-performance processor, which work together to create a 3D map of the surroundings in real time. That allows the drone to understand its environment and make decisions in real time. And then we have the S2 Plus is equipped with an RGB camera that allows for high-quality video and image capture. And then the X2, we have 2 versions, the RGB and an RGB and infrared as in the other one. And so I wanted to mention that because compared to other drone platforms, you know, what makes Skydio unique is that you can navigate in GPS denied environments, because our navigation is based on the 6 navigation cameras. So we have a GPS on board, but we don't need it to navigate. So when you are thinking about, you know, flying around a bridge like the O'Callaghan-Tillman Bridge, you're going to have like a lot of obstacles and, you know, lots of areas where you won't have access to GPS, the satellite signal. So, you know, while we are obviously providing those sensors to capture the data, we're doing it safely. So we remove the stress of the operator, who oftentimes is someone like Michael, a bridge engineer, that and we try to, you know, enable them to focus on the inspection versus on the drone operation, if that makes sense.
That does make sense. So I was actually wondering that. So if it's, you know, typically with drones, it would start with people having to fly them manually, and then they get programmed, you know, to follow a particular pattern. So you're saying that more often than not, the drone is somewhat flying itself, and there's little interaction with, you know, the programming or the users, and it's trying to kind of figuring out where it needs to be and recording the whole thing. Is that right?
So the obstacle avoidance is one of the applications based on Skydio autonomy, and that's always active. So the drone is, you know, can avoid and it will always avoid obstacles, you know, minimizing the risk of collision at all times. There's different settings for that obstacle avoidance, so you can reduce, kind of like think about it as a bubble that is surrounding the platform, the drone itself, and you can reduce that bubble, and so you can go in, you know, in confined spaces, in bridges, for example. You can, you know, find different, Michael will know the technical worlds, bridges that have to go within very confined spaces. So in that case, you will reduce the obstacle avoidance and can do, you know, fly safely in those environments. And there is like many benefits around, you know, Skydio autonomy that actually Michael can tell you about. But you know, the idea that the one of the biggest problems that companies such as Stantec face in terms of scaling up their drone programs is the cost that, you know, the investment that they need to do in order to train their bridge engineers to become extremely experienced pilots to fly in such environments. So with Skydio in you know, less than half a day, you know, actually literally in just an hour, you could, you know, just fly safely and make capture quality data in no time, basically.
Yeah, I'll kind of go back on that. If we can rewind too, when we initially were inspecting this bridge, you know, historically we did bring in conventional drones, I'll call them, early on, and that required advanced piloting and an additional, you know, essentially another body or two, usually two, to bring out into the field. And so that was essentially a pilot, just a pilot that knew exactly how the drone operated. It did not have obstacle avoidance, and it would take, you know, about a week to establish video of exactly what we had taken in the field. So when Skydio came along, that was a door open for the bridge inspector now to put on that pilot hat. Now that the drone, we're not necessarily needing an advanced pilot that has years of experience with these drones. We can put a bridge inspector behind that and put the advanced pilot in the drone and let the drone speak for itself. And now we're able to actually get closer without the fear of a drone striking the bridge and losing our data or worse happening. We're now the bridge engineer can do things even quicker than an advanced pilot could 2 or 3 or 4 years prior to that, just because of what's built onto the drone. And we use that to our advantage, both with 3D modeling or 3D scan, where the drone was flying itself for a majority of the flight, or even we did simple video as well. We came back with video and went up and down the columns just like we had done in years prior, but we did it much quicker and more efficient because we were up close and personal with the bridge and not necessarily worried about collisions.
Okay, so maybe you could just walk through me a little bit of an example. Let's say you've used the drone, you're kind of scanning along. Do you scan the whole thing at such a high resolution that when you go back and look at it and flag something for closer lookup, it can kind of just like digitally zoom in? Or do you then tell the drone to go back to something and you want to check it out? And does that need to be piloted or programmed? How would you do something along those lines?
I can let Alicia talk to the setup, I guess, behind 3D scan. But essentially, once 3D scan was in operation, the drone is flying itself, and I'm able to look at the screen and see what the drone is seeing. And again, since the drone is flying itself, I know that it's getting the correct overlap, I know that it's getting the correct pictures and everything that I need post-production, I can focus more on what are we seeing in the model itself, and I can be the inspector on the screen. So it works in 2 ways. One, I can, at the end of the scan, I can come back to key areas and take additional photos if I feel like I might need something else. Or additionally, we had a rope team on site. We could have sent them down to go look at a specific area and say, you know, we need hands on this area if we needed to, for whatever reason that we might have seen. But that's where it really comes into play is, you know, if I were to be manually flying the drone, I would have to be wearing 2 hats, right? Watching where the drone is flying, making sure I'm getting to those locations, and also inspecting the bridge. But by running that 3D scan, it actually, you know, served 2 purposes. I was able to get that 3D model on the back end, which was great to tell my story, but I was also to be able to watch everything that was happening live in the field while that data was being captured. It was kind of twofold.
Yeah, I can talk a little bit about the portfolio and the different solutions we have. At the moment, we have dock and remote operations, and then we have on-site operations, can I say it that way? And so the dock operations basically is which Stantec doesn't have yet. But the idea is that they can place a dock station anywhere, basically under the bridge, on a bridge, or nearby an infrastructure, and you know, have eyes on the sky in a matter of minutes. And you can, when and if you get a waiver from the FAA, then you can, you know, fully operate beyond visual line of sight, so meaning nobody on site, no crew on site, and then remotely operate the drone from wherever in the world. So that's a part of our portfolio. And then the other part, which is what Stantec is utilizing today, we have 2 platforms, the S2 Plus and the X2, and they both work with a controller and that you are on site just flying the drone. And for those 2, for that operation, we have 2 different workflows: the manual capture, which again has you know, additional value in terms of the Skydio autonomy. So we have the obstacle avoidance at all times. We have different workflows such as Scout functionality that can, track your controller wherever you go. We have different automated workflows. And then we have 3D Scan, which is a software platform that's for data capture fully automated. And so if you want to do a 3D model or a 2D model of your infrastructure, it basically takes you through a step-by-step workflow, and it enabled the pilots to capture enough data with enough overlap and enough precision to generate 2D and 3D maps.
In the video that I know we're going to be highlighting in this article, it mentions that the crew went from 6 to 10 rope climbers without the drones to using only, they said, 3 with drones. And why was it such a large difference? And what do the remaining climb inspectors do at that point? Is that just to follow up on those highlighted areas that need a more of a human touch, or are there other aspects that they're still working on?
Yeah, it was more a time savings in terms of weeks. So it was a 2-week long inspection trip. If you saw the columns in the videos, we had to rappel each and every side, essentially 2 sides of every column to get the full capture. So by removing the need to rappel every single approach column, it took away an entire week worth of work. But yeah, in terms of why such a large difference, it's mainly just time on rope, right? So I physically have climbed these. You can think of it's a 300-foot tall column, and you're manually climbing the entire thing. So you're descending down rope down, and you're coming up the other side, and that could take upwards of an hour to hour and a half in some regards to just one person to climb that column. When you add that up for, I'm going to say there's 8 columns at least on the one approach side that we were inspecting. That adds up to a lot of work on climbing and also snooping, people on the top of the deck that are watching you, everything. So that's kind of where the big difference came from. But the number of climbers, I would say, didn't necessarily change. It focused our energy more on the arch span, the central span that we were looking at. And also, like you said, puts people on watch to be able to come down and inspect certain columns when we needed to if we found something.
Okay, yeah, that video also mentions that the Nevada DOT, they said they saved $40,000, and you said you changed that timeline from 2 weeks to 1 week. Now, those probably are most likely in those man-hour costs that you talked about, but are there other savings, again, that aren't so obvious? And would there be that much savings for easier bridges, or is it because this is so difficult that it made those cost savings more dramatic?
It's not just necessarily just the climbers for 2 weeks. It's also everything that's happening on the deck that maybe folks aren't seeing, the traffic control personnel, the operators of the snooper trucks that were there, the officers that were on site to maintain safety on our all of those add up to hours. So yes, I would say a majority of it was just the man hours. But in terms of, a safety, it's a 1 week, one travel week performance that we could just get in, get out, and have the job done, and have more information back from that 1 week than we did in 2. So I would say that's where most of the savings would come from.
So how often is a bridge like this inspected? I imagine it doesn't change, but because it's easier to be performed, would it be done more often, or is it just there's a standard time between inspections and you're saving costs when you have to do them?
Yeah, there's a standard time. So the rule of thumb is every 2 years a bridge is inspected. There's factors that come into play that we can adjust that, but essentially when a bridge is born, it is looked at every 2 years, and that might shrink depending on its life or the deficiencies that might be within that bridge, or it might go up depending on other characteristics. But this bridge in particular, once every 2 years. It helps in terms of, the initial thought was to put drones on this bridge once every other inspection, so we can reduce the number of man hours on those every other cycle, but still satisfy the need from the FHWA to inspect these bridges the way they're mandated.
Okay, what about for using drones on I guess more normal bridges, or totally normal bridges? Are the same safety and cost savings similar, or again, does that degree of difficulty make a difference?
Yeah, the degree of difficulty definitely has a huge factor in costs. When we talk about smaller bridges, we might do what I would call a conventional bridge inspection in the matter of a day, or even less than a day, depending on its complexity. But what Skydio has enabled Stantec to do is to put a controller in the car with them. So we're able to deploy a drone on a simple bridge. Before, it didn't make sense to hire a pilot, bring a giant drone on site, and look at a 50-foot long structure. There's usually a lot of obstacles in play that would not allow it to, and the cost alone would not make sense. But Now it actually travels in my truck with me almost every single week that I go out and inspect what I would call simple bridges. And I can add more to my report, whether that be a 3D scan, video, or adding additional photos from a different perspective that we would not be able to do with any other inspection method.
So Alicia, I saw you were on the video that we're going to focus again. Are you on most projects, or like Michael was saying, does he then learn to take the drone out and do it himself, and Skydio kind of takes a step back?
Yeah, definitely. We were in the O'Callaghan-Tilmal Bridge. Parts like Skydio, we consider every customer almost like a partner. We love being, in the field with our customers, learning how they utilize the platform, any product gaps that we might have, and we kind of like build that relationship, very close relationship with each of our customers. So yeah, I've been on site a couple of times, but the team has been on site with Stantec team a couple of times. And any time that there is a project that they we might want to learn from each other, we just are very happy to do so.
You kind of have already explained some of the technicalities of the drones and the UAVs that I was looking for, but can we start by just backing up a little bit and giving me a little brief on Skydio's history and when it got involved in engineering applications? Was that from the beginning, and or did that evolve?
Yeah, I think Skydio was founded 2014, I want to say, by our three co-founders who met at the MIT, and where I think there's a very interesting YouTube video where they are already flying a fixed wing, actually, in a parking garage, fully like avoiding obstacles, and I think the flight was also fully autonomous. So I think the vision of the company is bringing autonomy in the drone space to enable and unlock workflows that can have a meaningful impact to in the infrastructure space. So as I mentioned before, Skydio autonomy is at the core at everything we do, and things like the obstacle avoidance, 3D scan, which is the workflow for automated data capture. So they are very good examples, or even the dock and remote operations are very good examples of where the company is heading.
Would you say that the technology and the drones kind of came first with the object avoidance and the scanners, and they just happened to fit into the infrastructure industry well, or was there any pre-thought of hey, these for bridge inspections would be great, let's do that?
I think well, first of all, I don't think Skydio is a hardware company. I think we consider ourselves an AI and software company, and so the hardware for us is only a vessel of the technology we are developing. And so while the company started in a different space, I think our founders and leadership has been really smart in terms of like identifying the different spaces and industries where AI in the form of drones can have massive benefit and impact. Call it infrastructure, inventory management, bridge inspection, public safety, surveillance and patrolling. There is like loads of applications where having eyes on sky and providing that information almost real time is almost critical for a lot of professionals.
And again, you did have talked about some of the special parts of the UAV, and it's kind of tailored. Like you've got several options, and you kind of tailored toward the project. So there is no really like a standard model or a typical this goes with that. You kind of you can tweak each one so that it's the right one for the job. Every
customer is different, like as in every customer uses and utilizes a different ecosystem, starting from their drone program all the way down to the data downstream and the different platforms and how they consume the data. Depending how, for example, the drone program, how mature it is, if they've been leveraging drones for a long time is different than, companies that are just getting started with drones. So every company is different, and that's, I mentioned earlier, Skydio, takes pride in every customer is kind of like a partner to us. And we don't sell hardware and then, we leave them on their own. We actually build that relationship because of the uniqueness of each customer. and how they utilize our platforms in the best possible way for the benefit.
My next question is kind of an opinion question. So do you think that either the drones can ever completely replace humans on inspections, or will there always need to be engineers on site for confirmation and oversight? And I'd love to hear from both of you.
I would never say never, right? I would never say never, but I think Alicia would agree, and she saw this physically on site, that an engineer is critical. And looking at bridge inspection in general, it's critical to have that person there and understand what they're looking at. And that's where Skydio really played a great role with Stantec inspectors. Is we're able to now bring the engineer and the pilot all in one platform. And I think the technology is growing. It's substantially grown since 2014, as what Alicia said, when Skydio came in. And so that's where I'll say, never say never, but at this current point in time, I don't see it happening anytime soon. The engineer still needs to be implemented. Whether one day we remove the personnel on site, the engineer will still be overlooking the data at some point in time. But it's so critical to have an engineer on site, see it firsthand, be able to touch the defects or touch the bridge, see what's going on with the bridge. That's incredibly critical throughout our infrastructure.
So you think that even doing it from remote access with a good sensor, you think it's still always going to be useful to have someone there who can see it, touch it, hear what it sounds like?
Yeah, I mean, remote access has its time and place, 100%. I think like drone doc was discussed here. It gives us a perspective of saying, do we need to get out there and see something that's gone on, whether it be a flood with recent events here that have gone on in the United States? Can we just look at how the bridge is behaving in a global perspective? That's where doc can sometimes come into play. But when we're looking at critical infrastructure, a lot of times our inspectors are taking their heads and they're moving them around corners, moving up into bearing seats, and we're crawling, we're climbing, we're doing a lot of different things. Yes, the drone definitely helps, but I would say that it's still very critical to have the engineer, the bridge inspector in general on site to be able to see these things. One day, I think we'll come to the day where drones will be able to collect all the information without me being there, and get that point. I just think at this point, a person is very important.
I couldn't agree more with Michael. Like I've been in the space for the last 11, 12 years. I've seen a lot happening. Like recently enough, ChatGPT has, everyone is like, they're taking over. I think we humans make technology as smart we are. Like the technology is becoming really, really smart because we are actually pushing our own boundaries. And I think Stantec is a very good example of, there's a lot to say in terms of like the added value when it comes to safety and efficiency, but we can't replace a human being and the judgment of an inspector making a decision whether this is a crack or corrosion or things like that. Machines will help optimizing that workflow, but I don't think they will replace the subject matter experts. I think Michael mentioned something doing the inspection project we did in the O'Callaghan-Tillman Bridge, that the same way new hires in Stantec get a laptop and a tablet, he'll like for every of them to get a Skydio, and I think by integrating drone data in their workflows, in the bridge inspection workflows, the Stantec team can work much more efficiently on site. They can go exactly where the issue is, and they can capture that data much more quickly and faster, enabling the team really to focus on high quality tasks. And ultimately the company will be able to diversify their services and hopefully driving more revenue and investing that revenue in smarter ways. But I think ultimately it will be an inspector or an engineer as Michael, who will be using that technology to perform their jobs faster, safer, and much more efficiently.
Where do you see Stantec going with its use of drones, not just for bridges, but for buildings and dams? How might they be used more in the future? And Alicia, from your end, where do you see your partnerships going with Stantec and other engineering companies heading toward the future? Where is this headed in the next, let's say 5 years, so we don't go too far?
Yeah, for bridge inspection in general, and for drone use at Stantec, you know, we're using it more and more to show, again, paint our picture. Picture's worth 1,000 words. So if we can paint our picture in terms of you know, a 3D model, or that'd be a video or something along the lines of putting our customers in the zone of, this is our area and this is what we're going to do. It helps with planning, it helps with every facet of infrastructure and engineering, inspection, planning, whatever it might be. So it's being used more and more, and the more drones become available and more economical, which they are, we're going to use them because it's very helpful in our day-to-day work. So from a global setting, it's just going to exponentially grow from here.
We're hoping to, you know, grow more and more with Stantec in our partnership, and you know, looking into dock and remote operations, and any upcoming platforms that we'll be releasing. And I think, you know, in the vision, the vision that I have in my mind for the next 5 years, obviously I would love to have a Skydio platform in every bridge in the country, obviously, and have, you know, the team, like Michael's team, communication almost real time back and forth with inspection data, right? So they can go on site, they can leverage 3D models, which I don't think we're that far away from these, you know, so that they can just walk, you know, visualize the 3D model as if they were like on site. And then once they are on site, they can just like real time going through any anomalies or any, you know, tasks that they need to perform on site. So yeah, that's kind of like, I guess where I visualize or envision for for Skydio and Stantec in the next 5 years.
And I'm going to piggyback on that and go a little bit beyond the 5 years. We think about the current events that are happening right now with the hurricanes, with the earthquakes, and natural disasters that are happening throughout the country. It's sometimes impossible for an inspector to get out to site immediately after after disasters happen. And if we have a dock or a drone of some kind on site, we can remotely go and ensure safety before a person actually can get out there. That's where I would really like to see the industry go, is to be able to remotely understand what is going on with our sites, what's going on with our infrastructure, prior to even setting foot on site.
I don't think I mentioned that, you know, Skydio, our platforms are designed and manufactured in the States, and you know, like some of the drone platforms have been banned from government agencies. So I think there's an element of it might be worth mentioning that.
I can discuss it with our clients. There's certain types of drones, and I won't mention manufacturers' names here, but other types of drones where my clients are not allowing me to fly certain types of drones that are not built in the United States on our sites. So it is a huge advantage. We had a number of them in Stantec, and we had to swap them out for a Skydio, essentially, or a US made drone.
Didn't know that. Is that kind of problem going to get worse, do you think, or is that going to be more of an issue?
Well, if you think about it, you know, like I don't want my data to go to end up in, you know, going through the Chinese government. So like there's an element of like, we have drone platforms are capturing data of our, you know, critical infrastructure across the world. And so I think that data needs to, you know, be in the right hands. So yeah, I think we will see a lot more, you know, momentum or a lot more happening on that space.
As bridge inspectors, we're looking at very key details, very specific components of the bridge that are very important to the bridge and to everyone's safety. To capture that data and have an immense amount of photos, video, 3D models of that, it's important that stays in the right hands for all industries throughout the country.